Yes, so as we were discussing, last class we did factorization, okay, which of course is the process of taking an expression, let's say 6x plus 12b, and transform it in such a way that it appears differently with brackets, okay? So in order to do that, you identify the highest common factor between the terms. In that case, you have two terms, and all the examples is two terms, 1, 2, 1, 2, 1, 2, which is 6 in that case. 6 can go into 6 once, and 6 can go into 12 two times. So you factor out 6, you open a bracket, and then you divide by this factor to know what comes in the bracket. 6 into 6 goes once, and you have 1x. 6 into 12 goes 2 times, so you have 2b, and then you close the bracket. So this expression and that expression are the same. The only difference, one is not factorized, and whereas the other one is factorized. Factorized meaning is to place into brackets. Good morning. So we just doing a little introduction before we begin. Let the others arrive. As we were saying last class, we did factorization, as you can see, placing an expression, transforming it in such a way that it appears now with brackets, and there's a highest common factor outside of the bracket. Okay, so factorization means to place into brackets with a factor outside. The highest common factor will be outside of the brackets, and inside of the brackets now will be the result after you divide by that factor. So for example, you have 6x plus 12b. Between 6 and 12, we have to identify the highest common factor, which is 6. And then you divide each term by that 6. So 6 into 6x. 6 into 6 goes once, you are left with x. Plus 6 into 12 goes 2 times, and you are left with 2b, and then you close the bracket. Okay, so this is the process of factorization. Okay, so that's what we did last class, and we did this for a variety of examples. As you can see, we did this for, yes? What the 6 doing outside of the bracket? The 6 must be outside of the bracket, because now, remember, we are just transforming the expression to look differently. We're not really changing or compromising its originality. Hear my words. When you factorize in, you are not compromising the originality of the expression. You are transforming it, but at the end, it will look differently, but it will be the same. Okay, look at that. Right. Welcome. Just to clarify again, look at this. Let's say you have an expression (10 over 20). 10 over 20. So 10 over 20 is a fraction. This has a value, 10 out of 20, okay? And that happens a lot in mathematics, transforming, making it look differently, but it's the same. 10 over 20. We can rewrite 10 over 20 in a different way, but it will have the same value. (10 over 20 is the same as 1 over 2. So you see how we're looking differently, but this is the same. It have the same value. 10 out of 20 is the same as 1 out of 2. We can still write this in a different way. 0.5. 0.50. So 10 over 20 is the same as 1 over 2, is the same as 0.5. So you can see now it appears differently, but it is the same value. And there's another way you can write 0.50 as 50%. So all these 1, 2, 3, 4 representations have the same value, but it's looking differently. So it's something similar that is happening when you are factorizing. Okay, it's the same expression, but it looks differently. Okay, so that's why the 6 must be there. Because now, yeah, just a minute, I will try another one. Because now, if we have, we should be able to go back to 6x plus 12. Listen to me. The 6 have to be there. Because we're supposed to be able to go back to 6x plus 12. We're supposed to be able to get back 6x plus 12, plus 12b. You understand? So the 6 must be there. If we take out the 6, then we will not be able to get back to 6x plus 12b. Plus again, we will not be able to see 6x plus 12b is equal to 1 is equal to this. We cannot say that. This is not true. So a student was asking what the 6 is doing there. The 6 must be there because we cannot say 6x plus 12b is equal to 1x plus 2b. This and that are not the same. The 6 have to be there because it's common, the highest common factor. Okay. Someone say a quick example before we move on. Let us say, for example, you have 10x, let's say 10x squared let's say you have 10x squared plus 12bx. Okay. You have to identify the highest common factor between 10 and 12 first. Factorization we are doing, better than me. We are factorizing. We are just revising factorization from last class. Just a reminder for the person that just arrived. So when you are doing that, you have to identify the highest common factor between the numbers first, between 10 and 12. What is the highest common factor? Because when you factorize in, the highest common factor must be there, multiplying, must be there in front of the bracket. So what number, when you factorize in, I repeat, there must be a highest common factor in front of the first bracket. So what do we put there? Between 10 and 12, what number is the highest common factor? A number that can go into 10 and 12, the highest one. The lowest one is 1. 1 can go into both 10 and 12, but it doesn't make sense to put 1 there. 2. And then x is also common because you can get an x in x squared and you can get an x in x. So x is also common. And then you open the bracket. Okay, then you open the bracket. And for you to know what coming into the bracket, you have to divide by each term by what you put outside of the bracket, by what you put in front of the bracket, by the highest common factor. So we have to multiply, divide 10x squared by 2x. So here we go. 10 into 2 into 10 goes how many times? 2 into 10 goes how many times? That's obvious, right? 5 times. 2 into 10 goes 5 times. And x into x squared. We just subtract 1 from the power. So you get x. Okay? Plus. Go back to the same 2x again. 2 into 12 goes how many times? Yes, what's 2 into 12? Everybody know that. Then you have your b, because there is no b there, so you must maintain your b. Now, x into x goes how many times? What is x divided by? What is 5 divided by 5? What is 9 divided by 9? 5 divided by 5 is 1. 9 divided by 9 is 1. X divided by x is 1. You don't have to write the 1. The x cancels out. Okay, any letter divided by itself is 1. 59 divided by 59 is 1. B divided by B is 1. X divided by X, the X cancels out and they close your bracket. So this and that is the same thing. Now look at that now. We're supposed to get that back. If we clear the brackets by multiplying, we're supposed to get that back. Get back the originally what we have. Remember, we divided to get the 5x and the 6b. So if we multiply is the opposite of division. If we multiply, if we clear the brackets, we're supposed to get that back. And I think we cleared brackets already. We multiplied and we cleared brackets already. What is 2 times 5? What is x times x? So we're getting back what we started for. So that's why we must have that factor in front of the bracket, so that when we clear our brackets by multiplying, we're supposed to get back what we started with. 2 times 6 is 12. 1 times b is b. X times 1 is x. Okay, we're supposed to get back what we started with. Okay, similarly, if we have to expand the bracket, we're supposed to get this expression back. 6 by 1 is 6. 1 by x is x. So you have 6x plus, and then you go back again. 6 2s are 12, and 1 by b is b. We're supposed to get that back. So this is what we're going to do now today, which is expansion, but expansion now of expressions that look like this. Expanding expressions to form a quadratic expression. Okay, that's what we're going to do today. These are factorized expression. You see the brackets? Once you see brackets, that expression is factorized. There's a factor outside. X plus 2 is the factor. X plus 3 is the factor. X minus 4 is the factor. These factors are more complicated than these factors we have there. We started with, because as you can see, these factors are just one number, one term. 2x is one thing. You don't see 6 plus something or 2x minus something. So these are very simple factors, and you just multiply by them. These factors we have there now are a little bit more complicated because they have 2 terms in a bracket. So these are the factors we're going to use to multiply to clear. Okay? So that's what we're going to do today.